Hello students, today we will be starting with chapter number 11, that is force and pressure. And in this chapter you will be studying about force and pressure, that what exactly is a force, why some actions are considered as push or pull, what are the causes of a force, and what are the different types of forces that exist on an object, and what are the effects of those forces in changing the state of motion and changing the shape of an object. And in the end, you will be studying about pressure that is exerted by solids and liquids, as well as about atmospheric pressure and that is exerted by the gases. In this video part 1, we will be studying about force and its constituents, and about pressure we will be studying about in the next video. So let's start with the introduction of the chapter, and the first topic is force. In science, a push or pull of an object is known as force. A push is a force exerted away from the body. For example, hitting a snooker ball, kicking a football, etc. are all the examples of the push. While pull is a force exerted towards the body, for example, playing tug of war, drawing a bucket of water from the well, these are all examples of a pull. So, if an object has to be moved, it has to be pushed or pulled. Force acting upon an object can be calculated with the formula that is given below. F is equal to m multiplied by a, where F is equal to force, m is equal to mass of object, a is equal to acceleration. And the SI unit of force is Newton, that is denoted by capital N. To let a force come into play, two or more objects must interact with each other. For example, an image is given below. If a man stands behind a car, the car doesn't move. If he pushes the car, he applies force and the car begins to move in the direction of the applied force. So with this example, you can understand that interaction between one object and another object is a necessary condition for the force to be in action. So next, move on to the characteristics of the force. Force depends on various characteristics, like when two or more forces are involved, the strength of the force, that is the net force, depends on the direction of each of the forces as well as its magnitude. When forces are applied in same direction, they get add together, whereas when the forces are in opposite direction, the net force is difference of the forces. So before going in detail further, we should be aware of the term net force. The sum of all the forces that are acting on a body is called the net force. So let's move on to the characteristics. First characteristic of force is when two forces act in the same direction, the net resultant force on an object is the sum of these forces. As you can see in the image, F1 and F2 are the two forces that are acting in the same direction on an object. So in this case, net force, that is the sum of all the forces, will be equal to F1 plus F2. And in the second characteristic, when two forces act in opposite direction, the net resultant force is the difference of these two forces. So you can see in the image below, F1 is acting towards the right direction and F2 is the force that is acting towards the left direction, and the magnitude of F2 force is more as compared to F1, so the net force will be equals to F2 minus F1, and the effect on the object depends on the net force acting on it. You can get a clear image of these four characteristics with these cases. This is the case 1 in which tug of war event is happening, and you can see in the right side only 2 persons are pulling a rope, while on the left side 3 persons are pulling the same rope. So you can see the magnitude of force on the left side is more as compared to the right side. So the movement will be towards the left side. In the second case, two persons are applying force in opposite direction to push the table. And in this case, there will be no movement. And in the third case, two persons are applying force in same direction to push the table. So here, the direction of motion will be in the same direction in which the force is applied, that is towards the right direction. So I hope with these three cases, you might have understood the characteristics of the force that is acting on an object. Now moving further, there are effects of force on an object. That what can a force do on an object? First of all, force can change the motion of any object. Force can make an object to move from rest position, or force can stop a moving object also. Like we have discussed earlier also with an example of a man pushing the car. Earlier the car was at rest position, and when the man has applied some force, then the car started its movement from its rest position. And also force can change the speed of an object also. Like if you are pedaling a bicycle and you are applying some kind of brakes, force on the brake, then you can control the speed of that bicycle also. And next, when we talk about the effect of force, force can change the direction of a motion of an object also. For example, if a ball is coming towards a batsman and that batsman is hitting that ball with a bat, that then at that time he is changing the direction of motion of that ball with applying the force by the bat. And lastly, force can also change the shape of an object. Like for example, whenever you are squeezing a spring or stretching a rubber band, or you are uh, rolling a chapati with the help of rolling pin, you are applying some kind of force, right? And that for example, when you have a dough and you are applying a force with the help of rolling pin, then in that case that dough will be converted into a chapati. So the shape of an object is changed. So these were some of the effects of force on an object. So let's talk about an exception also. Like you can see in a picture, we can see that a girl tries to push the ball, but the ball doesn't move because the force applied is not sufficient enough to push the ball. So thus, it is not necessary that force can always bring a stationary object in motion. That is one of the exceptions of the effects of force. Now, moving further, let's discuss about the different types of forces. On the basis of nature of the interaction between two or more objects, force can be classified into two types. First is the contact force, and second one is the non-contact forces. Contact forces are the forces which can be applied only when it is in contact with one another object. So, in these type of forces, contact between two objects is a necessary condition. And the example of contact forces include muscular force and friction. And when we talk about non-contact forces, forces which can be applied without contact with object are called non-contact forces. So we can say in these type of forces, the contact between two objects is not a necessary condition. Examples of non-contact forces include magnetic force, electrostatic force, and gravitational force, or you can say gravity. Let's talk about these examples in detail. First are the contact forces, and the example that we are going to study is the muscular force. Muscular force is basically the force applied by the effort of our muscles, or you can say the force exerted by the muscles of our body for performing various activities like lifting a heavy box, pulling a bucket of water, pedaling a cycle, and you can say even if we want to walk from one place to another, we are using muscular force. And along with the human beings, animals are also using this muscular force to perform various tasks. Then we have force of friction. Force of friction, you all are aware of this term because you have studied friction chapter in detail. So as you all know that force of friction is the force which opposes the motion of an object over a surface whenever it is moving in contact with that surface. For example, ball rolling on ground gradually slows down and comes to rest due to force of friction that is acting between the ball and the ground. And another example is there, if we stop pedaling a bicycle, it gradually slows down and comes to a stop due to the force of friction that is acting between the wheel, or you can say the tire of the bicycle, and the road. So basically, the force of friction is there to oppose the motion of an object. Next are the non-contact forces, and we will be starting with the magnetic force. Magnetic force is the force that is exerted by the magnetic objects or the magnets. For example, the force of attraction and repulsion between two magnets, and force exerted by a magnet on a piece of iron is also a example of magnetic force. So we know that like magnetic poles always repel each other, that is, they push each other away, as you can see in the images given below in the C and D image. And also opposite magnetic poles always attract each other, that is, they pull each other towards themselves. You can see this effect in the images A and B given below. So that is the magnetic force that is acting between two objects without in contact. So next is the gravitational force. Gravitational force is basically the force that is exerted by the earth on all the objects. The attractive force that a body experiences towards the center of the earth is called force of gravity due to earth, and it pulls all objects towards the earth. There are so many examples, like a coin or pen falls down when it slips off your hand, a ball thrown upward falls down, leaves and fruits falls to the ground when they get detached from the plant. Also, rainfall and all the waterfalls are the example that water flows downward. So these all are the attractive forces that are exerted by the earth on the object. Next are the electrostatic forces. Electrostatic forces are the forces of attraction or repulsion experienced by a charged body from another charged body or uncharged body. As we know that like charges always repel or push each other away, and the opposite charges always attract or pull each other towards themselves. So there are always some electrostatic charge present between two charged bodies or one charged and uncharged body. For example, you can see in the images given below. In the first image, a plastic straw charged by rubbing with paper is attracting a suspended plastic straw. While in second case, a plastic straw charged by rubbing with paper repels a suspended plastic charged by rubbing with paper. So that was electrostatic force of repulsion and attraction. So with this video, our force concept is over, and I hope you all have understood it very well. Thank you for your cooperation, and we will be studying about pressure and atmospheric pressure in our next video. Thank you.